This video covers similar triangles, and we will identify and use similar triangles using the AA, SSS, and SAS similarity theorems. So in this video, I'm going to talk about shortcuts for determining if triangles are similar using three different theorems. Actually, one is a postulate and two of them are theorems. A reminder, what it means for two polygons to be similar is that all of the corresponding angles are congruent and all the corresponding sides are proportional. And just like when we talked about congruency, two polygons are congruent when all the corresponding angles are congruent and all the corresponding sides are congruent. And that's a lot to find out, but when we dealt with triangle congruence, there was a bunch of shortcuts that we could use to determine if two triangles were congruent. Well, same thing with similarities. There are shortcuts for determining if two triangles are similar. We don't need to find out every single piece. So starting with the angle-angle similarity, it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. I don't need to find anything about the sides. I don't need to find out if they're proportional, and I don't need to find out what the third angle is. So here's an example of using the angle-angle similarity. This is actually a postulate, but I have two triangles, and I have triangle ABC and triangle EFG. I know two angles in each triangle. I know angle B is 42 degrees and angle C is 58 degrees. And then in the other triangle, I know E is 80 degrees and F is 42 degrees. Well, if E is 80 degrees and F is 42 degrees, if I add them together and then subtract their sum from 180, I get 58. So that means that angle G is 58 degrees because angle B and angle F are congruent, and angle C and angle G are congruent, then I know that triangle ABC is similar to triangle EFG by the angle-angle similarity postulate. Here's another example, and I've seen these a lot on the practice problems. We're not given any measures of angles, and we're asked, are these two triangles similar? And if they are, you have to say why. Well, I don't need to know any angle measures to determine if these two triangles are similar because I have vertical angles right here. So those two are congruent. And if I know that this line and this line are parallel, then that means using alternate interior angles, these two angles are congruent. Also, these two angles are congruent. So, but I only need to know two angles are congruent to use the angle-angle similarity. So that's enough to determine that triangle RQP is similar to triangle RNM because of the angle-angle similarity. I know that angle QRP is congruent to angle NPM because they're vertical angles. And then I know that angle Q is congruent to angle N because of alternate interior angles. And that's my reason for saying these two triangles are similar because of angle-angle similarity. The other triangle similarity shortcut is the side-side-side similarity. It says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. I don't need to know anything about the angles. If I am given all three sides of both triangles, and I can determine that those three sides are proportional to each other, then that's enough for me to say that those two triangles are similar. I'll do an example with this in a moment, but first I want to talk about the side angle side similarity. So this is the last triangle similarity shortcut. The side angle side similarity is if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So that's saying if I know that xz in this example to EG, that ratio is equal to ZY to GF, and then I know that angle Z is congruent to angle G, that's the included angle. So I know this side and this side are proportional to this side and this side. And the included angle, that means it's in between the two sides that I know. If I know the included angle is congruent, then I can say that triangle XZY is similar to triangle EGF. So the side-side-side similarity and the side-angle-side similarity are both theorems, and I'm going to do an example that uses both. Okay, so my question is, are these two triangles similar? Well, first I'll have to determine if the sides are all proportional to each other. So what I do on these problems is I look at each triangle and I want to pair up the sides of each triangle that are smaller, that are the smallest, and I want to pair up the sides of the triangle that are the middle size, and then I want to pair up the sides of the triangle that are the largest. So AC is the smallest side of this triangle, so it should be proportional to CD, the smallest side of this triangle. That should be the same proportion as BC, which is the middle length of this triangle, to CE, the middle length of the other triangle. And then AB, the largest length of this triangle, should pair up with the largest length of the other triangle, DE. So let's see if those proportions are all the same. So AC with 6 should be equal to, or AC over CD, which is 6 over 4, which reduces to 3 over 2. I'll label it. Please make sure you label everything. So that should be equal to BC over CE, which is 7.5 over 5. And 7.5 over 5 reduces to 3 over 2. And then AB over DE is equal to 9 over 6, which reduces to 3 over 2. So all three sides are proportional to each other, and so that means that triangle ABC is similar to triangle DEC. Here's another kind of problem that you see a lot. You have a triangle with a segment going through it, and it's asking you, are these two triangles similar? If we look at this triangle right here, MNP, we know two of its sides, and then if we look at this big triangle right here, we also know two of its sides, and we also know that these two triangles share this angle. So we know that angle M is congruent to angle M by the reflexive property. So if these two triangles are similar, they would be similar by the side angle side similarity theorem. So I want to know, are the two sides that are on both sides of angle M, are they proportional to each other? So is MN, side MN, over MR, that's that big triangle side, proportional to MP over MS, so MP over MS. So that would be MN over MR would be 10 over 10 plus 15, which is 25, which reduces to 2 over 5. And then MP over MR is 12 over 12 plus 18, which is 30, which reduces to 2 over 5. So the two sides are proportional. So therefore, those two triangles here I'll label it, RMS, that's the big triangle, is similar to triangle NMP, that's the small triangle, by the side angle side similarity theorem. Okay, I want to do one last problem, finding missing measures using similar triangles. So I might just have a diagram like this that says find x. Well, I'd have to determine, are these two triangles similar and which two triangles are similar? I'm going to have to write a similarity statement. So if this side so I know that this angle is congruent to this angle, and I know that because these two sides are parallel, that this angle and this angle are congruent. So with the AAA similarity, I know that that triangle QRS, order really matters here, QRS is similar to QTU. So with that information, I can find, or try to find, the value of x by setting up a proportion, because QR to QT is equal to RS over TU. So x plus 3 over 2x plus 10 is equal to 4 over 10. So I have my proportion set up. I can just do cross product, so this times this. So I would have 10 times x plus 3 equals 4 times 2x plus 10. Distribute the 10, so I'd get 10x plus 30, and then distribute the 4, so 8x plus 40. Subtract 8x from both sides, I get 2x plus 30 equals 40. Subtract 30 from both sides, I get 2x equals 10. And divide by 2, I get x equals 5. Okay, that's it for this video. Let me know if you have any questions.